There is no simple answer to the question, what is light? There's no way to satisfy the many contexts in which light is experienced, explored, and exploited. In this video, I will be discussing the physical attributes of light. In simple terms, light is energy. It's nature's way of transferring energy through space. When light travels between two places, so for example from the sun to the earth, or even from a flashlight to the sidewalk in front of you, energy is traveling between those 2 points. The energy travels in the form of waves, which is similar to the waves on the sea, but much, much smaller. We see this light or transfer of energy as color and brightness, but it's actually electromagnetic radiation, partly electric and partly magnetic, and it flows in a straight line. That was just the basics of light. To help understand light, you need to know where the light comes from. And the answer to that's simple: the sun and stars. But how do they make this light? It all starts with the atoms. And so all atoms have electrons, and like the planets in our solar system, electrons stay in the same orbit, unless electrons get kicked into a different orbit. If you add energy to an atom, which means heat it up, the electrons will jump to bigger orbits. And then later when the atom cools, electrons jump back to original orbits. And when they jump back, that's when they emit the light, which is a form of energy. Each electron that jumps back emits 1 photon of light. But then, what is the color of this light? This all depends on how big the jump between the orbits was. The bigger the jump, the higher the energy. The energy determines the color of the light. A blue photon has more energy than a red. So, the bigger the jump, the more blue it will be compared to red. All of this brings up the question of whether light is a particle or a wave. This is a huge controversy that, in fact, started hundreds of years ago. Scientists have argued over whether light is really a wave at all. Back in the 17th century, the English scientist Sir Isaac Newton thought that light was a stream of particles. But another great scientist, Dutchman named Christian Huygens, was quite adamant that light was made up of waves. And this began the controversy that still is present today. In some ways, light behaves just like a wave. Light reflects off a mirror, for example, in exactly the same way that waves crashing in from the sea reflect off sea walls and go back out again. While in other ways, light behaves much more like a stream of particles, like bullets firing in rapid succession from a gun. During the 20th century, physicists came to believe that light could be, in fact, both a particle and a wave at the same time. This idea may sound quite simple, but is actually a much more complex concept known as wave-particle duality. The real answer to this problem is more of a matter of philosophy and psychology rather than physics. Our understanding of the world is based on the way our eyes and brains interpret it. Sometimes it seems to us that light is behaving like a wave, while other times it seems like light is a stream of particles. There is no definite answer to whether light is a particle or a wave, which helps show how complex light is, and it is not completely definable. Now, moving on how light behaves. We're going to assume that light are waves for now. And light waves behave in 4 different and useful ways that are called reflection, refraction, diffraction, and interference. So the first thing is reflection. And reflection can happen in 2 different ways. So the first one is if you have a smooth, highly polished surface and you shine a narrow beam of light at it, you get a narrow beam of light reflected back off of it. And this is known as specular reflection. And the other one is diffuse reflection. And this is when you shine light at an object which isn't smooth and highly polished, which is what most objects are. And so when you do this, the reflected light is scattered all over the place. Reflection is a fairly basic topic that most people know about. And the next one is refraction. Light waves travel in straight lines when they're through empty space. But when it travels through other materials, it's not so straight anymore. When going through other materials, light waves tend to slow down, which makes the light waves bend, which is known as refraction. A very common example of this is when you put a straw in a glass of water. The straw sort of looks like there's a kink at it where the water meets the air. And this happens because the water is bending the light. The next way light behaves is diffraction. Diffraction is simply the slight bending of light as it passes around the end of an object, and the amount of bending depends on the relative size of the wavelength of the light to the size of the opening. If the opening is much larger than the light's wavelength, the bending will be almost unnoticeable. But however, if the two are closer in size or equal, the amount of bending is considerable and is easily seen with the naked eye. And now for the last way that light behaves, interference. If two light sources produce waves of light that travel together and meet up, the waves will interfere with one another where they cross. In some places, the crest of waves will reinforce and get bigger, but in other places, the crest of one wave will meet the trough of another wave and the two will cancel out. Interference causes effects like the swirling, colored spectrum patterns on the surface of soap bubbles, and the similar rainbow effect you see if you hold a compact disc up to the light. What happens is that two reflected light waves interfere. One light wave reflects from the outer layer of the soap film that wraps around the air bubble, while a second wave carries on through the soap only to reflect off of its inner layer. The two light waves travel slightly different distances so they get out of step. When they meet up again on the way back to the bubble, they interfere. This makes the color of the light change in a way that depends on the thickness of the soap bubble. When the soap gradually thins out, the amount of interference changes and the color of the reflected light changes too. So, as you can see, light is a very complicated topic and there's a lot to it. And it's very complicated to define all aspects of it, but this was just the basics. But thank you for listening. And here are my sources, and thank you once again.